Hey everybody, Mr. Stewart back again. So this is a second video in this series about connecting and creating multiple representations. So in the first video, we looked at how we could connect the graph to the pattern rule. Now the pattern rule or equation for us was missing, and we built that based on the information in the graph. And we determined that y, or which could be the total number of, say, tiles in a tiling pattern in any diagram, and whatever diagram that is, so x would be like the position number. And as you jump from one position to another, there would be some kind of a number that you would be adding or subtracting. In this case, we figured out that we would be adding 1 each time, and then we ended up having to add on, in this case, the number of tiles that would be in the 0th position. Okay, so altogether the pattern is y equals x minus 6, or at least that's our rule. So what we want to do now is, instead of refocusing on the graph, we want to go and look at how, on Earth, could we take the table of values and figure out the equation from that. Okay, so remember that we are looking for the y-intercept, which is -6, which we can see here. It's your y-intercept. And we're also looking for the rate of change. And remember the rate of change, okay? That's this value here, your rate of change. And on the graph, we kind of saw or figured out that it would be sort of, for every unit you go over, you would go up 1. So there's your rate triangle, 1 for 1. Or you could go 2 for 2, right? Or 3 for 3. So it all reduces down to 1 over 1, or a rate of change of 1. So we need to figure out those details, but in the table of values. So why don't we start with, let's start with the rate of change. Let's see if we can't figure out how to get this from the table. Right? Now, if you look at the table, and if you think about linear relations, many of us realize that there is a constant growth, that the patterns that we see are consistent and constant. But, if you look at this table right now, have a look at how it's increasing. So we start at -7, and then it goes up 3. Then from -4 to -1, it goes up 3 more. But then from -1 to 1, it's only a jump of 2, okay? Then over here, if you look at this, -1 to 2, that's +3. 2 to 5 is +3. And then 5 to 7 is +2. So it almost seems like the data we're given is inconsistent. It's, almost like not being able to tell if this information would actually give us a line. Now you could graph it by hand or put it in Desmos, and you would see the same line that we have here, guaranteed. But the thing is, you won't always have that graph or that access to graph it. So what would you do in a case where you just had the data in a table? That's what I want to work on with you, okay? So what I'm going to do is just move this again, and let's deconstruct or break down this table, okay? So let's make sure that we have all the information we need in front of us. So here we go. So let's start at the -1. Let's go up by 1 to 0, then to 1, 2, 3, 4, 5, and then so on. And then in the y, across from -1, we have -7. nothing for 0, nothing for 1, but for 2 we have -4, and then at 5 we have -1. Okay, so what I want you to think about now, and I'm going to move this again. Let's give ourselves some space here. We'll move this all over a little bit. There we go. Okay. Is think about how it's growing now. Okay? So have a look. So here we have increases of 1, and we have increases of 1 all the way through. Okay, same thing moving down that table. Now, on the right-hand side of the table, notice that we have a jump of +3, but in between, we should have 1, 2, 3 jumps. Same thing here, grows by 3, and in between, we should have 1, 2, 3 more jumps. Well, the question is now, how big are each of these jumps? Well, if we can see, and I'm just going to grab a highlighter here, we can kind of see that for an increase of 3, we have 3 unknowns, and those unknowns are all the same size. We can, easily say and confidently say that those increases themselves are all +1s. Okay? So +1, +1, +1. Same thing down here. So at the end of the day, what we're looking at is a comparison of how y changes with respect to x. Okay, so that's what you see over here in the graph. Okay, so let me demonstrate that again. I'm just going to erase this here for now. So I want you to focus on the increase in y. Okay, let's highlight that. Let's highlight these increases all the way through. So essentially what that means is as we start at one point, even at the y-intercept, as you go over 1, you're going to go up 1, and over 1, and up 1. So that increase right here, oops, sorry, wrong one, my bad, here, that's your vertical change. And then over here, if you focus on the x, all those increases are of +1. So then over here, there's your increase in x. Let me draw one more. Okay. Or maybe a couple. Oh, something's not working here. Okay, that has to be deselected. That's better. Okay. And let's get rid of this. Perfect. Yeah, same thing. So we go back to the table and use that information. So over 1 and up 1. So that helps us figure out our rate of change. So the rate of change, as we proved before, would be up 1 unit for every single unit increase in the value of x. So we work our way down, and now we happen to have, let me highlight this again. So this is what we have right here. We have our rate of change, which is just 1. Okay? That's how the pattern is increasing. Now what about this y-intercept of 6, or -6? Now we know what it is. It's right here. Okay, we've seen that before. But where is that in this table? Okay, so let's just kind of zoom in on that section. Okay, so let's be really clear about this. Okay, all right. So notice how the path we have here. So we start at -1, -7. And then we then increase by 1 unit to 0. And same thing on the y. right? We increase by 1 unit to the next value. So by increasing by 1, what that means for us is that this has to be -6. That must be the corresponding value if we use the pattern as shown. So at the end of the day, what we can do is come back here and we can gladly and boldly say that that is our y-intercept. So we have correctly found the equation. And that's video 3. Video 4 on the way.